Okay, so let's start answering this problem by making what I like to call a probability tree. So this is my favorite way of answering this type of problem. Okay, so what I'm going to do is the following. I'm going to make two branches here. And I'm going to say on the top one that somebody does not have the disease. Or they do have the disease. The odds of somebody not having the disease, we found out, is that 0.998, or sorry, 992, and the odds of them actually having the disease, 0.008. Okay, now from here they go and let's say they choose to go take this blood test. Two possibilities for the blood test. Either they test negative, or they test positive. Okay. And let's look at the odds of both of those. So somebody does not have the disease. So disease, no. They take the blood test, they test negative. Well, 98% of the time that's going to happen. The test is correct 98% of the time. So given they do not have the disease, the odds of them testing negative is 98. And we also figured out that then the inverse of that, or the complement, is the 0.02. These two probabilities must add to 1. Okay. Now, on the other side, let's say somebody does have the disease. They take the test. We know that the test is correct, and so if they do have the disease, they're going to test positive in 97% of the cases. So that leaves 3% of the time that they're going to test negative. Again, these two probabilities also must add up to 1. We looked at this 0.03 earlier as well. So we were given the 98 and the 97, and we calculated the 2% and the 3% here. Now, moving on, what I really like to get from here, which makes Bayes' rule a lot easier to do, is to get the probability of the ands. The probability of no disease, which I like to notate with a little bar over top. That means the complement, or that means no disease. So probability of no disease and negative. Well, to get that, take and times the odds of no disease by the odds of testing negative given you have no disease, which is this guy right here. And that gives you the odds of not having disease and testing negative. And that turns out to be the following, 0.97216. I'm going to put that right here at the end, 97216. Okay, next one, probability of no disease and positive is going to be the 0.992 times the 0.02. Okay, which gives 0.01984. So I'm going to put that right here. Okay. Next one, odds of having disease and testing negative. That's going to be the 0.008 times by the 0.03. Okay, and that gives us a very small probability, 0.00024. Finally, so that's this one right here. Okay, and finally the last one here. Probability of having the disease and testing positive is going to be the 0.008 yet again. Sorry, I'll just clean that up a little bit here. Times by the 0.97, and that gives 0.00776, which goes right here. Good. Okay, so we're well on our way to figuring out our probabilities. We've got all of the ands now. What we need to do next is we need to figure out, based off of all of the ands, our next step will be we need to figure out what are the odds of somebody testing negative, and then what are the odds of somebody testing positive. Okay, so let's have a look here at the times where somebody tests negative. It's here and here. So it's this probability and this one. So in total, the total percentage of time that the test returns a negative are these two here. So just add them together to get the probability of testing negative. That turns out to be 0.9724. Okay. Because those are all the cases in our tree here that we test negative. And then to figure out how often we test positive, well, here are the probabilities here and here. So just add them together to get the total percentage of the time that the test returns a positive result. So just add those two numbers together and we get 0.0276. So we now have the probability of somebody testing negative and the probability of somebody testing positive. Note, one little note here, if this makes any sense, these ands that we got, they are out of the whole entire group, so that's why we can use those to figure out our overall probabilities of positive and negative, if that makes any sense. Whereas this 98%, the 2%, the 3%, and the 97% we had before were from specific groups. So the 98 and the 2% were out of the people who did not have the disease. And the 3% and the 97 were out of the people who did have the disease. So we couldn't add up any of those numbers to actually get our odds of negative and positive. We have to add up the ands here, if that makes any sense. Okay, now from there we're actually ready to go do what's called Bayes' rule. So let's have a look at the rule and then let's jump back into actually solving this problem.